Namaskar. Welcome to the channel Anka Ananda Aharan, that is extracting happiness from the teaching learning process of mathematics. In the previous video, we have discussed about some of the aspects of vector space, subspace, basis, rank of a matrix, linear dependency, independency, and the relation between rank of a matrix and linear dependency and independency. Today we will discuss one of the significant topic, that is basis and dimensions. This we will discuss today. So what it is? Consider a vector space V. So here let B be a subcollection of vectors of V. That means B is a subset of vectors of V, having elements of B as V1, V2, V3 up to Vn. That is, these are n number of vectors which constitute my set B of capital V, of vector space V. Now, what do we mean by span of B? Span of B means set of all vectors obtained from the all possible linear combinations of vectors of B. That means I will multiply any scalar to V1, another scalar to V2, and another scalar to Vn, like this. All vectors will be multiplied by a particular scalar, and after adding them, whatever new vectors we will get, if we will collect all of them and form a set, that set is span of B. That means if V belongs to span of B, then there exist scalars C1, C2 up to Cn such that V can be written as a linear combination of V1, V2 and up to Vn. That means if any vector belongs to span of B, means it is a linear combination of vectors of B. Now the question is, how to claim that span of B is equal to the vector space V. So you select any arbitrary vector from the vector space V, write it as a linear combination of vectors of B, then if it can be written, then we can claim that V is span of B. Arbitrarily selected any vector you take from V, if it can be expressed as a linear combination of vectors of B, then we can claim that our V is a span of B. Same thing is written here. So here, now what we are going to discuss. Basis of a vector space. A subset B of V is a basis of V if and only if this B is linearly independent, the set B is linearly independent, and span of B is equal to V. Okay, here dimension of vector space V can be considered as the number of vectors of B. The number of vectors that are present in B is nothing but the dimension of V. This is dimension of V. Okay, so to find out dimension of a vector space, we have one of the options that let us find out the basis of it, and how many vectors are there in the basis will give us the dimension. But every time this is not the only way, there are several other ways to find out dimension of a vector space. Now there is a relation between basis, dimension and all those things. Any vector space may have several bases, but a basis can span only one vector space. Control Z. The basis can span only one vector space. Similarly, for any k-dimensional vector space, any k number of linearly independent vectors okay, let us forget about it. So what we are getting, for any k-dimensional vector space, any k number of linearly independent vectors form a basis for the vector space. That means suppose I have a vector space of dimension 3 and I am getting any 3 linearly independent vectors from that vector space. That means I am getting a basis of it. But if I have less than 3 number of vectors, linearly independent vectors, then even if they are linearly independent, it is of no use because they cannot span the whole vector space. A number of vectors less than the dimension cannot span the whole vector space, and number of vectors, hence they cannot form a basis, and number of vectors more than the dimension of a vector space cannot form a basis as they cannot be linearly independent. Okay, in a k-dimensional vector space, maximum k number of vectors are linearly independent. K plus 1 or more vectors are always linearly dependent. Next is 4 fundamental spaces of a matrix A. A matrix A with m rows n columns, that is m cross n matrix, be a matrix with m number of rows and n number of columns and rank A, has 4 fundamental spaces associated with it. They are column space, row space, null space, left null space. How to get what is the meaning of column space? It is span of columns of the matrix A. That means set of all linear combinations of columns of row vectors of A and columns of A. And what about row space? It is the row space of A is the span of row vectors of A, that is set of all linear combinations of row vectors of A. Here the vectors means we consider them as columns. So row vectors we will write as a row with a transpose symbol in it. Next is null space of A. So what is the null space of A? Set of all vectors x which are multiplied with A to give 0, that is Ax is equal to 0. If I have Ax is equal to 0, then x is a null space vector. And what about left null space? If x is instead of x, I multiply y from the left hand side of the given matrix and I am getting a 0 vector, or A transpose of y is equal to 0. For all such y, we will get the null space of A. Now, without finding the basis for the 4 fundamental spaces, we can find out the dimension of these 4 spaces. What are the dimensions? Dimension of column space is rank of the matrix. Dimension of row space is also rank of the matrix. Dimension of null space is number of columns minus rank. Dimension of left null space, number of rows minus rank. Now one more observation. Suppose I have a matrix with 3 rows, 4 columns. So here m is equal to 3, n is equal to 4. So naturally each column, so this is m, this is n. So each column vector is a subset of R to the power m. Similarly, each row vector is a subset of R to the power n, because n number of components are there. That is, number of columns is same as the number of components in a row vector. So it is R to the power n subset. Left, first of all, null space. If I multiply a vector x to this matrix, so it will have surely 4 components: x1, x2, x3, x4. So that means it has 4 components. That is, it is also a subspace of R to the power n. Similarly, for the left null space, it will be multiplied A transpose. A transpose means how it is: 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. This is my matrix. I will multiply a vector y, that is y1, y2, y3 with this matrix to get my zero vector. How many zeros? 4 zeros. 0, 0, 0. So here, that means how many components are there? The number of columns of A is the number of components of a left null space vector. So it is R to the power m. Number of components in a column vector is same as number of components in the left null space vector. So it is R to the power m. So later on we will prove, later on, not now, that these two vector spaces are orthogonal complements of each other, and these two vectors are orthogonal complements of each other. What are they? The meaning of orthogonal complement we will discuss in future videos. Next, to find out basis of column space of A, what are the steps we should follow? We are expected to find out echelon form of the given matrix A by applying elementary row operations on it. Then we have to identify the pivot column positions. For example, suppose I have a matrix 1, 2, 3, 4, 2, 3, 5, 7, 4, 8, 12, 4, 8, 12, 16. Suppose this is the matrix. Now, in its echelon form, what will happen? Directly in 2 steps, we will find. Directly, we will apply 2 operations. R2 minus 2R1 stored in R2, and R3 minus 4R1 stored in R3. Let us apply these 2 operations. How much we will get? 1, 2, 3, 4. This is 0. This is minus 1. This is again minus 1. And this is minus 1 again. So what about this matrix? It is 0, it is 0, it is 0, it is 0. So now we got in the echelon form how many pivots are there? How many pivots? This is a pivot and this is a pivot. Okay, so what are the pivot columns? First column and second column are the pivot columns. That means I will write this and this. So what is basis of C of A? Column space of A. How to write down? This is, I will write it as a set of vectors. That's a curly bracket. 1, 2, 4, comma, 2, 3, 8. Okay. So there is no issue at all. Next question is, what about the dimension? Here two pivots are there, that means rank is 2. So here rank is 2. So what is dimension of C of A? It is rank or number of vectors in the basis, but best method is rank method. If only dimension is asked, then you should go for rank. If basis and dimension both are asked, then we should go for basis and calculate it, the dimension from the basis. Okay, so what is the dimension of column space of A? In this case, it is 2. Next target is to find out basis of a null space. Basis of the null space of a matrix. For the row space basis, just find out A transpose and then find out its column space basis. Everything will remain same. Only first step we have to take is we have to find out the A transpose. Then all the steps of column space basis we have to follow. Now to find out basis of null space of A, what we will do? First step is apply elementary row operations on A to get the echelon form U. Then locate the pivots, identify the pivot and free variables. So what are pivot variables? What are free variables? The variables corresponding to pivot columns are pivot variables and all other variables are free variables. Now we have to assign one free variable with 1 and all other free variables with zeros. We should repeat this process till each free variable is assigned with 1, 1. Now using ux is equal to 0, we have to find out the pivot variables and hence the unknown vectors x. We will be getting the number of free variables is same as the number of vectors obtained. So we are expected to write them as a set to get the basis of null space of A. Now let us find out it. And to find out basis of null space of left null space of A, simply just we have to find out A transpose, then we have to repeat all the process of basis of null space. Now let us find out for this matrix, for the same matrix, basis of null space. So here what we will write, its echelon form is 1, 2, 3, 4. 0, minus 1, minus 1, minus 1. 0, 0, 0, 0. Okay, this into x1, x2, x3, x4. 3 cross 4, 4 cross 1, the resultant will be 3 cross 1. It is 3 cross 1. So now let us write down the, first of all, what are the pivot variables and what are the free variables. These are, so it is corresponding to x1, this is corresponding to x2, this is x3, this is x4. So what are the equations and what are the free variables? x1, x2, x3, x4. It is pivot, rest all are free. So here I will assign 1, here 0, here 0, here 1. Now from this equation, what is the second equation? Minus x2 minus x2 minus x3 minus x4 is equal to 0. So here first this is 1, this is 0. So x2 is equal to x3. x2 is equal minus x2 is equal to x3, so x2 is equal to minus of x3, so it is minus 1. What about the next value? It is 0, still it is minus 1, no effect because equations coefficients are same. Now the next equation is x1 plus 2x2 plus 3x3 plus 4x4 is equal to 0. First assignment is it is minus 1, it is 1, it is 0. It has no contribution, it is finally plus 1. X plus 1 is equal to 0, so x equal to minus 1. Then what we will do? Here also it is minus 1, here it is 0, here it is 1. So it is minus 2 plus 4, that is plus 2, so it is minus 2. So I got my basis for n null space is, what is basis? Basis of n of a is equal to, in the curly bracket I will write minus 1, 1, 0, comma, minus 2, minus 1, 0, 1. This much. So we got basis of null space. Also, to find out basis of left null space, we have to take the transpose of A. Then we have to apply all the method, all the process that we are making or involving while finding basis of n of A. So it is with this we should conclude this video, and in next video we will discuss further more aspects of vector space, basis, 4 fundamental spaces, their dimension, as well as complete solution, left inverse, right inverse. All these are very significant for anyone who is doing any study of linear algebra. So have patience and please be involved for these concepts. Thank you all for your patient listening.